Solving real-world physical science problems. In this video, you are going to explore some types of problems that can be solved using logarithms. For one, measuring acidity in a solution using the pH scale. 2, measuring sound intensity with the decibel scale. 3, measuring earthquake intensity with the Richter scale. Let's take a closer look. Sample problem number 1, the pH scale. The pH scale is used in physical science to measure the acidity or alkalinity of a chemical solution. pH is equal to the negative log of H+, which are hydronium ions, measured in moles per liter. If the pH is 1, it's on the acidic side. If the pH scale is 7, it's neutral. And if the pH scale approaches 14, it's alkaline. Tomato juice has a hydronium ion concentration of approximately 0.0001 mole per liter. What is its pH? The solution. To find the pH of tomato juice, substitute its hydronium ion concentration into the equation. So pH is equal to negative log of H+. So we'll substitute in 0.0001 and then we'll solve. We'll get the answer 4. So we know the pH of tomato juice is 4. Blood has a hydronium ion concentration of approximately 4.0 times 10 to the negative 7 mole per liter. Is blood considered to be acidic or alkaline? Here is your solution. Substitute the hydronium ion concentration of blood into the equation and use the scientific calculation to evaluate the common logarithm. pH, as we said before, is equal to negative log H+, which is negative log 4.0 times 10 to the negative 7 from the question, and we get 6.4. Blood then has a pH of approximately 6.4, which is below the neutral value of 7.0, so it's considered to be slightly acidic. Orange juice has a pH of approximately 3. What is the concentration of hydronium ions in orange juice? In this question, we're working backwards. We know the pH of the orange juice, and we want to find the concentration of hydronium ions. Rearrange the equation to express in terms of H+. So we know that pH is equal to negative log of H+. Negative pH is log of H+. 10 to the negative pH is equal to H+. That takes rid of the log. Substitute the given pH and solve for H+. So H+ is 10 to the negative 3, which is 0.001. So our solution, the hydronium ion concentration in orange juice is 0.001 mole per liter. Interesting. Here's one more. Which has a greater concentration of hydronium ion, orange juice or tomato juice, and by how much? The pH and hydronium ion concentration in tomato juice and orange juice are given here in the table. The pH of tomato juice is 4 and of orange juice is 3. The hydronium ion concentration is moles per liter. Of tomato juice is 0.0001, orange juice 0.001. So we'll do a comparison ratio and find that orange juice has a greater concentration of hydronium ions. We'll put orange juice on the top, 0.001, divided by the concentration of tomato juice, 0.0001, and it works out to be 10. Notice that a pH difference of -1 or of 1 corresponds to a 10-fold increase in hydronium ion concentrations. Sample problem number 2, the decibel scale. Some common sound levels are indicated on the decibel scale shown here. The difference in sound levels in decibels can be found using the equation beta 2 minus beta 1 equal 10 log I2 divided by I1, where beta 2 minus beta 1 is the difference in sound levels in decibels, and I2 divided by I1 is the ratio of their sound intensities, where I is measured in watts per square meter. Sample problem number 2. How many times as intense as a whisper is the sound of a normal conversation? The sound level in normal city traffic is approximately 85 decibels. The sound level while riding a snowmobile is about 32 times as intense. So what then is the sound level while riding a snowmobile in decibels? Here is your solution. Substitute the given decibel levels for a normal conversation and a whisper for the ratio of their sound intensities. So beta 2 from our chart is 60, normal conversation. Beta 1 is a whisper, which is 30, and that's equal to 10 times the log of intensity 2 divided by the intensity 1. 60 minus 30 is 30, equal 10 times the log of intensity 2 divided by intensity 1. So 3 is equal to the log, by moving the 10, dividing it into 30, of intensity 2 divided by intensity 1. Three then is equal to log of I2 divided by I1. We can remove the log by setting 3 as the exponent to base 10, and getting 1000 is equal to intensity 2 divided by intensity 1. So our conclusion then is the ratio of these intensities is 1000. This means that to the human ear, a normal conversation sounds 1000 times as intense as a whisper. B. The ratio of the intensity of the sound while riding a snowmobile to the intensity of the sound of normal city traffic is 32. Substitute this and the given decibel level for normal city traffic into the equation and solve for the decibel level of the sound while riding a snowmobile. Again, the formula, beta 2 minus beta 1 is 10 log intensity 2 divided by intensity 1. So beta 2 minus 85, which is normal city traffic from our chart, is equal to 10 times the log of 32, which is the intensity given in the question. So beta 2 minus 85 is equal to 10 log 32. Beta 2 then would be 10 log 32 plus 85, which is 100. So the sound level while riding a snowmobile is approximately 100 decibels. Now, let's look at the Richter scale. The magnitude M of an earthquake is measured using the Richter scale, which is defined as M for magnitude is equal to the log of I, the intensity of the earthquake, divided by I subscript 0, which is the intensity of a standard low-level earthquake. How many times as intense as a standard earthquake is an earthquake measuring 2.4 on the Richter scale? And B, what is the magnitude of an earthquake 1,000 times as intense as a standard earthquake? So, for A, we know that M magnitude was 2.4. We will substitute that into the equation and solve for I divided by I subscript 0. So 2.4 is equal to log of I divided by I0. Again, remove the log by using 10 as the base and 2.4 as the exponent. And that works out to be 251.19. So this means that if you have an earthquake measuring 2.4 on the Richter scale, is approximately 215.19 times as intense as a standard earthquake. When you hear about different areas in the world experiencing earthquakes, they're always measured in measures according to the Richter scale. Next time, remember what this means and you'll know how intense it was. Now for B, we're going to substitute 1,000 in for the intensity to solve for M. So we will get M is equal to the log of the intensity ratio, I divided by I0, equal log 1,000, which is equal to 3. So an earthquake that is 1,000 times as intense as a standard earthquake has a magnitude of 3. Good to know. Next time you hear these terms, pH scale, decibels in level, and the Richter scale, you'll know what they mean and you'll be safer.